Hi again, welcome to the Garage Ampere. This time around, we're making, at least trying to demystify a little bit how to cut gears, make it simpler, as simple as possible, because this can be pretty, pretty complicated sometimes. But we'll try a new approach and see what we can do about it. It's neither metric, neither imperial. Counting teeth and holes into a dividing wheel mean there's no standard in that. It's just plain numbers. So let's get on with it. In order to at least have the basics about it, you need a couple of gauges, preferably you got big teeth like this is a 2 pitch down to 4.5 pitch. You got intermediate size gauges. You got up down to pretty small teeth, like 72 teeth. And just the way to measure them, there's a pressure angle. Let's see if you can see pretty well on this. You got the two standards are 20 and 14.5. I'll show you close-ups of these, like you can see the 20 on top and the 14.5 in the bottom. See the difference in the angle. You need to measure the wheels. Let's say that this wheel here, that's already done. It's a 12 pitch. The angle is, let's try this here. This is a 20 angle. And this is a 14-degree pressure angle. See how it meshes better, it matches better. There, there's a big difference, so you have to get the right pressure angle. Otherwise, it's not going to make a pretty good, a pretty good meshing, a pretty good match. So, with a few gauges and the dividing plates, the indexing wheels or whatever, however you call them, and rotary head. So, let's get on with it and try to see how it's being done. Another quick tool for this is Bruce Whitham. He's got a channel in Australia. Get her out, and he made some kind of a small gauge like that you can get from his channel. You can measure pretty well the pitch. There you go. This is a 12 pitch, and see how it meshes. This is a let's say a 20-degree pressure angle gauge. I think he has just check on his channel. I think he has different pressure angles. So practical tool for from a fellow YouTuber. Something you most likely will need to achieve this job is a rotary head, and also the plates, the corresponding plates to go on this head. Some have pretty much lots of holes in there. So if you get multiples, I'll show you how multiple works. And most of the time, you got the number of holes in each row written on the straight line there, more or less. Some are double-sided because this one is double-sided. It doesn't go across the thickness of the plate. Also, you got some which got less holes in there. So you have to find a common denominator. To be seen in a few minutes. There you go, I see you. This one is going right through. So next step is to get into the dividing part. Friend Philippe from Phil's Projects, he just came to me and said, I need to cut wheels to make, I don't know what kind of a tread on his Graziano lathe. And he said, oh, it's going to be easy. I need to cut gears, 12 pitch, 14.5 degree pressure angle, 31 teeth, 47, 58, 64. He said it's going to be very easy because I got in my indexing wheels or plates, I got 31 and I got 47. At least he thought that these two were going to be super easy. So I said, okay, explain to me how you're going to do it. So he said, no problem. I put the 31 hole indexing plate and advanced 31 holes in there. I put the 47 and advanced 47 holes in there. The that wasn't good. So I had to. I mean, he's a friend, so I wasn't letting him try that and be sorry about spending a few hours not succeeding. So I just got to his place, and you'll be seeing in a few minutes. Like after this, you'll be seeing how he cuts the gears and how he manages the actual part of making them. So let's get back on this. First things first, a rotary head. Most of them, I didn't say all of them. Just read my lips. Most of them are having a ratio of 40 to 1. So if you crank one time, you make 9 degrees advance on the 360 degrees for full circumference. So it means that 40 turns of the hand crank will bring you a full rotation. So you want to make, let's say in this case, 31 spaces. Let's say you got a full rotation there, clocking there. You want to make 31 spaces on there. So it's going to be different than the 40 because if you go with the crank one full turn, whichever indexing plate you put on the rotary head, sorry, it's going to make you a 40 teeth gear every time. Whichever one you go there and you go a full rotation. So you need to act a little bit differently about this. So Philippe was pretty much right about using the 31 indexing plate, but with a little bit of nuance. So if you get a 31 hole indexing plate, you're going to be needing to go a little bit above one turn to make a full, full, let's say a full circumference gear. If you get 40 teeth, you go one turn. But if you make, let's say, less than 40, let's say you make that 31, it's going to be one turn plus a few holes. Let's say because the spacing between the teeth and the 31, the spacing will be plus spacing. Let's say the teeth here. Let's make them just like straight like that. 31 is going to be this much, and 40 is going to be this much. So you need to go a little further in the rotation to make a larger spacing there. I think you can follow this pretty good. Okay, next. Now, how much further you need to go? This is the key for the whole process. Let's say you got 40. You're going to make a ratio there. Divided by 31. It's going to give you 1 time 31. You subtract 31 from 40, leaves you 9. Here, very important, you do not go decimal, you go fractional. And 9/31. What does this mean? This means that you're going to have to go one full turn plus 9 holes. This is the let's say this row would be the 31 spots there. So you go 31 plus, don't count them, it's not right, but the 9 holes. This is going to give you, after you did the whole circumference around the table at 360 degrees, this is going to give you exactly a gear with 31 teeth. Oh, this is moving. This is not very stable. But from there, you always get a perfect gear. The only thing that matters, you have to go to get the right circumference in there, and you need to be able to get a very stable platform to or axle to achieve this with the gear cutter. That's what about the 31 teeth. Okay, now let's go about let's say if you want to make a 40 teeth, that's very simple. You take any of the wheels, always come back to the same place there. One rotation, stop there. One rotation, stop there, cut the gear. One rotation, stop there, cut the gear. Simple. Now you got 47. How do we make the process? Let's get at it. Okay, now how about we got a bigger number than the ratio of the table. 47. So it's going to be the ratio of the table, 40 over 47. You want to make 47 teeth, and you got 47 holes in the plate. So your plate here, let's say we start at 0. 47. But you know that the spacing in there, sorry about the not being very good. This is a 40 tooth, and this is a 47. See the spacing there? This is not exactly proportional, but spacing there for 47 is smaller than the spacing for 40. So it means that you're not going to go a full circumference on this. And it's going to be exactly 40 holes. Let's say you go get your crank, 40 holes there. And then you repeat that for 47 times, and you get a gear with 47 teeth. Pretty simple for that, because we got these, these here. Now he comes with 58 and 64, and in this set of indexing plates, those numbers are nowhere to be found. But believe me, we can make the wheels, we can make the gears with that. Now we're making a 58. So because I'm using here I'm using the examples from Philippe. I think that could demonstrate the principle of how it's all going to be going. Now we're going to be making the 58. It's still our number, the ratio here, 40 over 58. Okay, you divide 40 by 48. You always stay fractional. Do not go decimal. 40 divided by 2, 20. Divided by 2 here again, because if you divide the top by 2, you got to divide the bottom by 2. You'll stay in the same ratio. So 58 divided by 2 is 29. Now this cannot be divided anymore. Let's see if 29 here means something in the indexing plates we got. We got an indexing plate with 29 holes in it. We're all set. So it's going to be the indexing plate. 0 there. We got 29 holes in there, and we're going to be going for 20 holes. We're going to be counting 20 holes, and so on and so on. That's going to make our our gear. Let's see. The plate is a 20. Sorry, the plate is a 29. Get out of there, yeah. 29, and we're counting 20. The spacing there. Okay, this goes for the 58. So we're all set. We're making a 58. Doing 58 times this move. Now, okay, let's go for the next example. This time we still get our number 40 here. 40. We need a 64 teeth gear. What we're doing, we're dividing by 2. We could be dividing by a little bit more, but anyway, dividing by 2, dividing by 2. If you want to take a shortcut, you divide here by 4. You can divide there by 4. But let's divide by 2 first. We're going to get 20 on 32. Do we get a 32 hole indexing plate? We do not have one. So this is still divisible by 2, so it's going to give you 10 over 16. Let's try to see if we get a 16 hole plate. We get a 16 hole plate. This is exactly what we're going to be using to make the 64 teeth gear. So once again, I'm sorry if I repeat, but this is the 16 hole indexing plate. And we go, once again, 10 holes past the 0 there. We make 10 holes. We're all set. Let's take one of the examples there, and we'll go in the rotary head to see how we fix the sectors and just a rotation of it. Just we'll get you started, then you go see Philippe how he makes his own gears using these exact calculations. This is a dividing head, and one of the indication you're going to be looking for on your dividing head is this here. It says that the full turn of the cranking handle will give you 9 degrees, so it means that the ratio is 40 to 1. If you divide the, let's say, 360 degrees per 40 turns, that's going to give you the 9 degrees. So that's where it comes from. Right here, we'll be using the indexing plate with the 47 holes row. Next thing we'll be installing is this is the sector arm. This is adjustable. This is going to be used to get your spacing and keep up with the spacing you got. Let's just clip this on there. There we go. This is going good. Next thing you have to install on this is your cranking handle. Come on, you there. There you go. Now, this here will have to be adjusted into the 47 holes row. Let's just make this solid. There we go. There's the sliding area there where you can have this slot and slide this. Take it easy. You punch this into the 47. Haha. Anyway, believe me, it's right in the 47 row of holes. You tighten this up. Now, like we just mentioned before, this is the 47 holes plate. We're going to be putting the arm there with the pointer right into the 47. Okay, now that the pointer is into the first row there, the sector arm is right on there. We're going to give ourselves some space. So we're going to start counting like we just previously seen on the board, 40 holes, not counting where the pointer is sitting in now. So 1, 2, 3, 4, 5, 6, 7, 8. $39 and $40. Exactly where we need it to be. So with the sector arm, first hole there that we didn't move, last hole there 40. We're making this tight because this needs to stay this spacing here really needs to stay at the same place. So putting the pointer to the first hole. In principle, you would have a gear blank here. You would start making your blank. First tooth. Second time around, you go in there, you advance 40 holes. Make sure your sector is advanced. You're going to lean this first edge there right on the pointer. And again, this is going to be a 40 hole space in between again. There we go. You go, leave the, let it go. Always release in one direction. If you go past, it's going to, you got to catch up on the backlash. So you come back a little bit more, come back again, drop it in, make your gear. Never forget to advance your sector. There you go. This is the third gear tooth, and this is another advance of 40 teeth. Sorry, 40 spaces. And again, go cut your tooth. There you go, another 40. Make sure you always make it right. Never forget to advance your sector. Arms, there we go, and so on and so on and so on. That's the way that it should be done. Now you're cutting gears. When cutting gears like that and needing some specific amount of holes or whatever, you need to divide and until you get to the right amount of holes. Or if you don't have the right, let's say the right indexing gear plate, you may have to make one or get one or whatever, because there are times that sometimes you don't, you get stuck. Okay, now you can wake up. That's it for the action. You go see Phil's projects. My friend Philippe is going to be making the actual gears, the blanks, everything installed, lining up on the truck and everything. The easy part now is this.
Look who's doing all the work again.
Monkey number 2. Monkey see, monkey do. So, oops. That's going to be a job for the orthodontist. Straighten teeth.